Thank you. Hi, I'm John. I do sort of sysadmin and cloudy DevOpsy stuff, and I have some opinions on these things that I'm going to share with you today. Well, I mostly prefer working with smaller companies. I've also worked with RightScale and seen RightScale's clients, some of whom have deployments to fill data centers and their problems. But I don't think most businesses ever really get to be that sort of size. So I mostly view things like Docker from the perspective of small and medium businesses, rather than big data center filling monsters. I'm going to talk about a metaphor I've seen to describe different ways of managing servers, pets and cattle. But I'm also going to add cloned sheep as another type of server management and discuss how we can turn cloned sheep into immutable cattle. Pets are servers that are hand-built, sometimes called special snowflake servers. If a pet gets sick, you have to nurse it back to health because replacing it with another pet that's effectively the same is impossible. Pets are what happen if you set up all your servers by copy-pasting instructions you found on the internet. Sorry. Pets often have cutesy names picked from a naming scheme. If you called your server bilbobaggins.example.com, it's probably a pet. Almost everyone starts out building pets, and there can be places where it makes sense to use hand-built servers, even in highly automated infrastructures. Continuous integration build servers can be really tricky to set up automatically sometimes. Cattle are built using entirely automated processes. If a cattle server gets sick, you shoot it in the head and you build a new one. They're entirely interchangeable, with any given instance of a cattle server being as effective as any other. And cattle are the result of automated server build processes, and often have auto-generated names like prodapp143.example.com. So where does Docker fit in? It seems obvious that Docker-produced containers are going to be cattle. The whole purpose of Docker is to create an image that can be relaunched trivially. But I think that a naive approach to Docker risks producing not cattle, but cloned sheep. Cloned sheep was a reference to the famous Dolly, the sheep that was the first mammal to be cloned at the Royal Institute in Edinburgh. But I used it here to mean a server that is itself disposable, but is built on an image that can't be recreated automatically. Runtime problems with cloned sheep are easy to resolve. Kill the sheep and launch a fresh clone. But deeper maintenance issues, like ongoing security updates, require exactly the same kind of response as pets. The images have to be nursed by hand and then rebundled. This maintenance issue increases with age, as eventually the base image that you use to build the sheep goes out of support, patches dry up, and only a complete rebuild can help you. Cloned sheep aren't a problem unique to Docker or containers. In fact, they're common in cloud deployments, where bundling a custom image enables simple auto-scaling or redundancy tools to function. Anyone who's spent time bundling Amazon AMIs has probably been making cloned sheep. So I say you risk producing cloned sheep rather than cattle, but it's not immediately obvious that cloned sheep are necessarily worse. If you're building a bunch of VMs using Chef and the Linux distro you're using goes out of support, you're going to be facing complete rebuilds to get patches and support. And that's just the same as those trendy guys who are all using containers, right? Well, not quite. Most configuration management tools are flexible enough to do their stuff across multiple OSs, never mind different releases of your favorite Linux distro. In most cases, you'll find updated components already exist in the community, and they may even work as direct drop-in replacements. Launch a few staging instances to make sure all your custom stuff still works, and you're pretty much ready to move over in the best case. Are there cases where cloned sheep are preferable to cattle? Yes, definitely. Leaving aside the immutable server movement, as we'll be coming back to it later, there's one very good reason to build and boot your instances from images, and that's speed. If your primary use of server images is to enable scaling application servers, then it's going to be pretty important that new instances get up and serving traffic as quickly as possible. Servers configured at boot time using configuration management tools will always take longer to be ready than image-based approaches. Your cattle might need to register themselves with a central management server, download and install all the appropriate packages, maybe build some stuff from source, configure a bunch of your application-specific stuff, and this all takes time. I've seen auto-scaling systems where new nodes took half an hour or more to finish this process and be ready to serve traffic. There's ways to speed things up, avoiding building things like Ruby from source, and instead finding or creating OS binary packages instead as a common optimization. But it's telling that one of the most commonly suggested and used optimizations is to build a new base image with your standard prerequisites already installed. That is, go halfway to building a clone sheep anyway. Now, only a naive approach to Docker will create clone sheep by my earlier definition. You need to produce your images using a manual Docker run command on the command line. And I don't think many people are doing that for long, at least once you're past the just playing stage. The use of a Dockerfile means the image can be generated automatically, and all our clone sheep problems go away, right? Well, not quite. A Dockerfile is about the most primitive method of configuration management possible, basically a simple shell script. Configuration has moved on a bit since we manage things with shell scripts, and tools like Chef and Puppet enable a lot of advanced functionality. Things like auto-discovery of services, reusable components, fine-grained control over the build environment, like deploying version X of your application and staging version Y in production. A Dockerfile is more like recording your session of building a Snowflake server and then playing it back each time. It wouldn't really wash from modern configuration management, but it is better than doing it by hand each time. One area I find particularly useful with configuration management tools is reusability of components. When my client asks me to build a MySQL server, I don't need to write a MySQL Chef cookbook from scratch. I can build on existing cookbooks written by the community. And this makes a huge difference to both the speed and reliability of the solutions that I can produce. There's ways around this limitation. Docker Hub provides pre-built base images that you can use to build on, but I'm not convinced that they're necessarily the best solution in the long term. Relying on pre-built images is a bit like using an application that's only distributed as binaries. If there's ever any issues in the future, like the underlying platform going out of support, you can't fix them unless you have access to the original source. In this respect, any image you create that's built on pre-built images in this way could be considered a clone sheep rather than cattle, even if you're using automation to do further configuration. Immutability is where the metaphor kind of breaks down, since what we really want is immutable cattle. That doesn't really make any sense. Immutable servers open up a new approach for reliable app deployments. By doing a full replacement in place for each app server, you guarantee no legacy cruft, or just this one's hacks on production, and you avoid any temptation to keep state, including logs, on what should be stateless interchangeable application nodes. It also lets you roll back releases just by picking a previous image to boot the instance from. In fact, by keeping the history of the built images, you can roll back in time and avoid other issues, like updated OS packages which introduce conflicts with your application. Now, there's no particular reason you have to use Docker to deliver an immutable architecture. You could build custom AMIs as part of your CI process and boot Amazon EC2 instances from them. But Docker presents a particularly accessible and friendly way to build images, while bundling AMIs, fairly or not, is sometimes considered a bit of a black art. It's important not to underestimate how valuable the appearance of accessibility can be. The steepness of the initial learning curve can determine whether or not a technology gets broad acceptance or not. Immutable infrastructure isn't without issues. You need a lot of upfront infrastructure work to benefit from it, and it's not terribly helpful in cases where you absolutely do need to maintain state, like database servers. But it's a good tool for operations people to have available to them. So how are we going to improve creating immutable infrastructure with Docker? Well, earlier I mentioned service discovery is a potential benefit of using configuration management tools instead of the Dockerfile approach. An area that's critical for a lot of uses of a platform like Docker, especially when using immutable infrastructure. CoreOS uses Docker to run services, and they provided a tool, etcd, to handle service discovery. Now, CoreOS just had its first stable / production ready release, but etcd hasn't yet, and relying on it in production just now might be premature. A lot of the Docker ecosystem is like this. Everything is very new, and for a traditionally minded conservative sysadmin, that can be off-putting. Even Docker itself only reached version 1 in June. All the tooling around containers is still very new, I think some of it might have a way to go before it can be really production ready. But new tooling and processes are emerging from the main configuration management tool providers. Chef, Puppet, and Ansible are all talking about how to use their tools to build Docker images. And hopefully, as they develop and mature, we'll see less of the risk of cloned sheep and more of the benefits of immutable cattle. Thank you. If anyone has any questions, I'll try not to answer them.
Any questions?
So this is a bit of a sort of open-ended one, but have you been following the System D team work on immutable servers? They're trying to sort of do something very similar where basically you can they come up with sort of a way of looking at Linux that produces immutable servers. I don't claim to entirely understand it. They're getting some very advanced stuff now. But have you been following that and sort of interested if you have any comments on that, the ideas behind it?
No. or rather, it's on the list of things that I need to read. It's a long list.
Anyone else?
So, Weave was released on Tuesday, and one of the somewhat interesting things about it is if you go and look at its Docker file, it's got from scratch, because it's not actually using a distro at all. Do you think Docker is going to take us into a sort of new generation of beyond the distro, where we're just pouring into the container exactly known dependencies for the application that we're going to run?
Realistically, no. I think that people will build on existing OS images and rely on the equivalent of package maintainers to deal with it when they go out of support. I think it would be nice if what you said happened, but in practice, people won't do that because it's too much work.